Multi-kill.
Hello, my name is Nikolov. I'm an assistant professor at the computer graphics group at Aalborg University, Denmark, and today I'll be presenting my talk called FPS, Foundational Programming Skills in University Game Development. Well, programming can be extremely challenging to novice learners at university level. It requires a diverse set of skills: algorithmic understanding, programming syntax learning, abstract thinking, understanding how different tools work, testing, understanding errors, and debugging code. And when we combine this with the additional requirements connected to game development, like learning game engines, level building, animation and rigging, physics engine understanding, prototyping and testing, this can become a barrier to entry that is too high for a lot of students, making them unsure of how they would be able to continue. The multifaceted nature also makes learning from traditional resources like books and exercises quite problematic. It requires a combination of multimodal learning techniques, such as, of course, books and exercises, tutorials, be that video tutorials or step-by-step written tutorials, light coding, or paired programming. But how do we address some of the most burning problems in learning game development? And how do we find a happy medium between making interesting exercises and make them meaningful in pedagogy and learning? As well as how do we get students to get past the blank canvas approach, where they sit in front of a project and don't know how to start, where to start from, and what to do. Well, a very powerful tool in programming game development teaching is the idea of constructivism and reverse engineering. We have seen in multiple research papers that constructivism can help understanding concepts of game development. It can help introduce the ideas behind games in a more easily digestible way, where students can focus on redesigning or reverse engineering parts of a problem. This is specifically powerful for serious games and educational games, as well as the idea that games as a concept can be used to explain more complex patterns like mathematical concepts, physics, and so on. As well as the understanding that starting with development is more important than making something that's perfect, and learning starts from building something simple and building on top of it. But where do we go from here? We've seen that reverse engineering and recreating games can help with programming and game development. But how do we build upon this? looking at the state of the art, we see that a lot of the games here are old school arcade games like Super Mario, Pac-Man, Arkanoid, and so on. But why not take it further with something that we can see that it's very much one of the most widely played and understood game genres. If we look at something like PC games revenue for 2024, we can see that one of the main ones is the shooter genre. It represents quite a large chunk of the market, which means that it also represents that a lot of people had tried at least one first-person game. And why not try these first-person shooters as a medium of education? They represent important milestones in game development. Like one of they spearheaded the jump from 2D to 3D development with games like Cybercop. They popularized the use of texture polygons with games like Catacombs 3D. They have been used as demonstration of modern rendering and visual techniques for a long time. Can It Run Crisis was a meme for a lot of years in the 2010s. FPS games also contain a lot of the main requirements to master if you want to work with 3D development, like level building, rigging, animation, physics, interactions, camera work, and so on. And it's a good test bed for programming math because a lot of the requirements in game development math can be boiled down to requirements that can be put in games that are first-person shooters. Having said that, first-person games are still rarely used as vehicles of learning. If we look at some of the state-of-the-art research that features first-person shooters, mostly they are used for very little for education, with some research in 2008 on information literacy through first-person shooters, and in 2021 on how to use first-person shooters to disseminate research and understanding. But mostly a lot of the research is focused on reflexes and player skills, on the problems that are associated with modern first-person shooters like Call of Duty and Battlefield in propaganda and warfare, and in small cases as test beds for deep learning. Can we change that? Well, that's what we're trying to figure out with this talk and this research. Before going into what is the current work, we need to talk a little bit about what has been done in the previous years. In the last 4 years, from 2022 to 2025, as part of the course Programming Interactive 3D Worlds in Aalborg University, Denmark, the ideas in constructivism and reverse engineering have been central. The approach was to look at something famous or complex games that are widely known in pop culture, extract the most important parts of them and rebuild them in a short amount of time. So the idea is to take something that is widely known and take it, extract in the student's opinion what is the most important part, and try to implement it. It would not work as good as the initial inspiration, but we will be able to learn a lot of, through how it was built. In some of the most important parts that we focused on and that we learned about were meshes, lights and cameras, physics and collisions, ray casting, animation, level building, pathfinding, particles and noise, and shaders. The initial results from this study were published in 2023, and from the feedback from students and looking at the hand-in mini projects, we could see that on average, the mini project that was around rebuilding these games took around 15 to 19 hours of student time. We got a wide array of genre of games and the positive outlook of students. They were very interested in building these games, but not only building them, but also trying to bug fix them, test them, and document them. With these initial positive results and feedback from reverse engineering approach and the constructivism, we were expanded with the introduction of pre-class demonstrations where students could show off their exercises and get feedback from others, effectively giving the possibility of discussion. An emphasis on first-person shooters as a demonstration platform, as they were by far the most popular genre of games being reconstructed as mini projects. A lot of students were discussing them and showing them off, as well as the introduction of the first-person shooter, the definitive FPS documentary by Robin Block and David Craddock, as a tool for reflection and discussion in a workshop as part of the course, where students would be able to watch parts of the documentary and were given some times to discuss and think about what they saw, how their own work, struggles, and problems could be referenced in the work of some of the famous first-person shooter developers, how games that were built 20 years ago more or less have the same problems the students are facing. And what we saw is that students took the stories and struggles of seasoned game developers and they could put themselves in their shoes. They identified with some of the experiences, like using new technologies to them, understanding mathematical concepts, making games that should be fun, challenging, and engaging. The concept of biting more than they can chew, the problems with scoping, asking for help, and working in a team, as well as best practices in development. This is why, for the newest iteration of the course, we took all the FPS games based on the documentary and used them as an initial inspiration workshop, where students can read a little bit more about them and use them as inspiration for their mini project through the semester. In this workshop, they also could discuss different games, different concepts. They can write some of the main things that they would feel would be problems, how would they fix them, and so on. Together with this course, we also wanted to do a workshop where we wanted to distance students from game development engines like Unity, Godot, and Unreal, and give them the possibility to try to build something as a like Wolfenstein 3D clone in a live and pair programming exercise using only C++. This, of course, would be quite hard for students in Bachelor, but would give them the possibility to follow along and learn how to do raycasting from scratch, understand perspective projections, linear algebra, transformations, directional lighting, and so on. An example of this, what the students would be able to build is something like this. And this example was taken from Mike Chizis from hackday.com. The current changes, some additional stuff that we wanted to also do is we looked at the self-reported mini project timetables that the students were required. These timetables were fully self-reported, so whatever the students said, we take at face value. And we can see that the first-person games were, again, year from year, a higher and higher percentage of the games that were built. So students were very interested in doing that and were influenced by the workshops. Students worked on their mini projects an average between 15 and 20 hours in 2022 and between 19 and 28 hours 2023 and between 25 and 32 hours in 2024. The mini project requirements did not change. This just shows that students, of course, there is a difference between the different cohorts, but we can also think that maybe the additional workshops were helping the students get more interested in the subject. In their semester evaluation, students specified that even though the work time was high, this is something that we need to address, they enjoyed the possibility to create and demonstrate a deconstructed version of their favorite games. They specifically mentioned that this helped them understand concepts from mathematics, physical interactions, pathfinding algorithms like A-star, things that would be very useful in their further studies. We also wanted to do a postmortem. We reached out to a lot of the students that have finished the course in previous years with an online questionnaire. Currently, we still don't have all of the data as we're gathering them, but we asked them, for example, what were the topics that they learned they could use from the course in later courses and in their later work. And we can see that knowledge about transformations, raycasting in physics and collisions were one of the main things that students took away from. We also see that shaders were not as successful, and we're going to discuss this in a little bit more. And we also asked them to give some positive and some positive things that the course gave them, as well as some negatives and things that they would feel need to be changed. Some quotes from the questionnaire. I think it worked really well. Each lecture basically introducing a new aspect, and we got to exercises related to it, and the mini project was also connected to it. It was fun to work with first-person games as an element, awesome with the mini projects, and we were happy to show them off. Also, just in general, have a mini project that could be implemented, and we can learn from it. Some of the negatives is the students felt that they needed additional explanations or procedural generation. So they wanted to learn more how to do first-person games like Minecraft. And some of the negatives are also that they lacked enough understanding on shaders and rendering pipeline, so they would want more exercises and a deeper dive into them. In the future, we would like to continue the development and using first-person games as a teaching material through building on the idea with the Wolfenstein 3D workshop, where we would have dual workshops. One would focus on math and programming and procedural generation. That would be this C++ building from scratch a Wolfenstein 3D clone. And one that focuses on levels, visuals, and shaders with minimal math and programming, but would use a low programming engine for first-person games like easy FPS editor CE, where students would be able to build a more fully fledged prototype